Okay, so the question being, if you've got an object that has multiple forces acting on it, that's not what we wanted to do. And you want to find net work. Stylus is not working. And you want to find net work. How do you know what theta to use? Because, of course, net work is net force cosine theta d. So the thing to remember is that this is theta between net force and d. So you have to find the net force. Now you're going to have, in this case, you would have two different thetas because you have an angle here, you have an angle here. You would be using each of those thetas to find the components of that to do your sum of forces. The theta that you're going to use here is the angle between the net force, whatever that net force is, and let's see if I can eyeball this. Let's say that the net force ends up being there. Okay. And this object is moving along the line of the net force. So then the angle between the net force and the motion of the object is 0. And really, as long as you're resolving your forces first, it's pretty much going to always be 180 or 0. The book gives it to you as though you might do this. Well, I'm pushing, let's see, I'm and I'm going to draw this in. This would not be part of our force diagram. It's a terrible person. Now this person is pushing down and forward on this box. The theta between, and the box is moving this way. So they're saying, well, it's, this component of the force is the force that's actually doing the motion of the box. So they want you to use the cosine of theta, but again, it's still cosine of the angle between the force and the motion. I don't like the way they handle it, is what I'm saying. And I think it makes more sense for most people to resolve the forces first, and not rely on some general rule about, oh, it's always the cosine of theta. Well, yeah, which theta if you've got multiple forces? And, basically it comes into play if you have an object move, if you're looking at only part of the work, like in the ramps where you've got gravity, friction, and somebody pushing on the object or pulling on the object. If you're looking at work that's being done in opposition to the motion, it's cosine of 180. If you're looking at work that's being done in the same direction as the motion, it's cosine of 0. So it basically just gives you the -1 or not. Yes, ma'am?
You observe the students' problems on their work and stuff. On the conceptual, is there anything that we find that's hard to understand or hard to I don't understand just multiple missed questions that you help us more on?
Conceptually?
Last time was kind of weird for us to visualize and try to see it from.
Yeah, and you know what? That question, yeah. And I actually clarified the wording on that because it had been tricky in the past. And people would say, well, in the moment, what, before their feet leave the ground, after their feet leave the ground? So I clarified it. And I had people who had circled, who had all the right stuff but then didn't trust their instincts. So, who I shall